Hello, welcome back to Model Railroading 101. I'm your host, John Abaticola. Last time on Model Railroading 101, we took a look at JMRI and Digitrax. John Wiley showed us how to hook up a computer to a track using a Digitrax DCC system and a loco buffer interface. In this episode, we're going to head to the Santa Cruz Mountains to Rich Murphy's place so he can show us how to use JMRI with NCE. As a bonus, we're also going to get to see Murf's DCC box. This contraption was introduced briefly to us the first time Murf appeared on Model Railroading 101 last year in the episode that compared NCE versus Digitrax. Just a quick reminder here, this program is intended to introduce you to, and in some cases show you how to do cool things with your model railroad. Because of the nature of a program like this, it's recorded ahead of time and edited, and some things inevitably get left out because the presenter can't show you every possible variable. Sometimes things are omitted because they're simple enough for you to find out about on your own. Also keep in mind that this program is not being presented as a vehicle for manufacturers or hobby shops to advertise themselves. So we usually don't go into detail about where to buy something or find a product that's easy to find with a simple internet search. If you see a product used in a demonstration on the program that piques your interest, your best bet is to first check the credits and the video description, and if you don't find it there, go to your favorite search engine or your local hobby shop if you have one when the program's over and look for it there. All right then, let's go talk to Murf.
Hi, it's Murf. I'm going to be talking today about connecting JMRI to two different types of NCE systems, a Power Cab and a Power Pro. Use different connectors for each of those, but basically everything else is the same. So if you have a Power Cab, I'm sure you're already familiar with the basic components of the Power Cab system. You've got the controller head and you've got the panel that actually mounts. You also have, if you look inside, here is the back side of the panel right here. And you'll notice that it's connected by a cab bus cable to another board. That board is the Power Cab USB connection board. So you can see that it actually ends up, if you look at it, this is a standard USB-B printer cable like you would use to connect a computer to a printer. It plugs right into the end of the USB panel for the Power Cab. So I have everything mounted into my programming box. And the reason I did that is that the Power Cab panel kind of is just a PC board and it flops around, and I wanted to make sure it was protected. Also, when I did that, I also connected the USB cable up to a USB port on the top side of the box. So we're just going to plug that in. And we're connected to my computer now. Okay, so once you start Decoder Pro, bring up the Preferences panel and check your connection. You should have, in black, the serial port designated. On a Mac, it's cu. Whatever the name of the interface is. In my case, it's cu.slab_USB to UART. You're going to be connecting with a system of Power Cab. Connection prefix is N. And it's the manufacturer of NCE. At this point, if all of that's there, check your defaults. When you check your defaults, everything should be set to the NCE connection. And we're ready to go. Now I have an engine on the programming track over here, and I'm going to ask it to identify it. I think I've actually already got this in the system. You'll notice that it's actually selected the right locomotive, Canadian Pacific 8753, which I've designated as CP 8753. I can bring it up. And here we are with all the information for CP 8753. The other thing I can do, if I move this window out of the way, a little bit easier way of selecting things, since I have the correct engine selected here, I can bring up a throttle on the JMRI screen. This allows me to check things out. You notice by blowing the horn, I've actually got the sound going. It's really loud right now, so let's change that.
Yes, please, let's change that. It's too loud.
So we're going to bring up the sound panel over here. Sound levels.
I can't hear you.
And we're going to bring the master volume control down.
What? The engine's too loud.
And we'll let it start up, and hopefully the engine isn't going to be drowning us out. And you'll notice that's not nearly as loud as it was. The nice thing about this, using both JMRI and the throttle on the JMRI panels, is you can actually program something into the engine and see immediately what the effect is. We go to sound, and we take a look at what horn we have. Here we have the air horn as the K5LH, and if you play that, and we want to change it. Let's select a different horn. Writing the CVs out by selecting the alternate selection here. Selected a Nathan M3 just to try it out. So you can see, we changed the horn, it immediately took effect, we can test it out. That's the really nice thing about having one of these setups for JMRI set up to do all your work right at your workbench. So we just went through the basic stuff needed to actually hook up an NCE Power Cab to a computer and get JMRI started up and using the system. Let's go into my other area where I've got a NCE Power Pro system that uses a slightly different way of connecting to JMRI. So we're back in my layout room, and here I have an NCE Power Pro system. And really the biggest difference is just the cabling, or the connection from the NCE system to the computer. So the Power Pro system has a serial interface on the front of it. This is like the old days, for those of us old enough to know, of the DB9 serial connector. And we have to convert that into a USB cable in order to connect to most modern computer systems. So you get a serial to USB converter. It's really fairly simple. And then we just have to select the right input in the JMRI preferences in order to have everything all connected. And after we get it all connected, it all just runs the same as it does on the Power Cab. The big thing is to actually connect the computer to the NCE Power Pro station. You'll notice that the front of the Power Pro has a DB9 connector. We're going to take a serial line cable with a DB9 connector and plug it in to the front of the command station. From there, that serial line goes into, in my case, a trip-light USB to serial converter. Comes in with a DB9 here from the serial cable, and then it just plugs into my computer in an open USB port. So on the software side of things, when you use these USB to serial drivers, you're going to have to download the driver for that particular interface. Look to the manufacturer site in order to get that. So I just started Panel Pro on this system, and you'll notice that we came up with an error. And I did this on purpose, really, to show you that you can sometimes get an error message on the screen that says that it can't find the device. In this particular case, I've unplugged it. Sometimes it happens if you move which USB plug it's in. So first of all, the best thing to do at this point is quit Panel Pro. Plug the system back in, and let's see if it comes up this time. It's still having a problem. This time we're going to go in and we're going to have to go to Preferences. And there they are. we're going to come in, and even though we had the right thing selected, we've got to come down to the new one and select it again. And it's still coming out red, which usually indicates a problem. We're going to save that, and we're going to go ahead and quit. And we're going to come up again. And let's see if we get it this time. This time you see everything's coming back up. I've got my Y throttle up. In this case, I'm using Panel Pro because I use this to control my layout. So I'm getting my schematics up for the layout. It's important to pay attention to the messages coming up when JMRI starts because they're going to tell you whether or not they can actually communicate with your control system, with your NCE system. This is one way to actually get it fixed. Sometimes the USB to serial driver I've seen can get stalled on the way up. That's why I actually keep the interface right here. If I actually need to reset this, I used to actually have to reboot the system and get it all going again. Nowadays, if I really want to reset it, I can just unplug from the end of the USB to serial adapter and plug it back in. All I have to do then is restart JMRI. I hope this helps. It's one of the more confusing things about using this system. There are some quirks to it, but once it's up and running, it's really just a wonderful system to work with. So we've had a few questions about my JMRI programming box. This is an evolving project that started a long time ago when I first started getting into the hobby. I became involved a little bit with the Fremo guys here in Silicon Valley. And one of the things one of the members had, Eric Eggle, had a thing that he called DCC in a box. And I thought that was a pretty cool thing to have. And so my first effort was actually making a small Fremo module with a computer running JMRI and a power cab and all that kind of stuff. And then I found that I was using it for programming engines a lot. And I thought, well, it'd be really nice if I had that for HO or N-scale engines and that sort of thing. And so I moved it into a small tackle box kind of thing, really the simple kind of toolboxes. And I cut out a masonite panel and glued a strip of track on it, and then had the various components of the NCE Power Cab system kind of in the box. And I would take it and I would have all the stuff and I'd put it together and I'd start programming things. And after a while, the latch on the box broke and everything tumbled out. It wasn't a lot of fun. So I was in search of the new JMRI box, and I went to Home Depot and found a nice positively latching box. That was one of my criteria. The other thing is that I wanted a box where I could have a longer programming track. It's really important if you're going to make one of these things that you can fit your longest locomotives onto the track. So this is the box that actually fit the criteria at Home Depot. And it's got a nice solidly locking latch here on the front that clips in, and it holds really well. It's got a nice deep box, which allows me to take a lot of accessories with me, including putting the throttle inside the box. And then it allowed me a little bit of space on each side to mount the power cab panel on the top of the box, which was important to me. I wanted to be able to supply power to it. So I got an interface much like a computer, and I actually used a computer power cord in order to supply power to the box and turn it on and off. Thought, while I'm at it, I might as well have outlets so that I can provide power to a computer if I'm on the road. So this acts almost like a power strip. Also, it has USB ports on it in case I need to charge my phone because I'm going to use Y throttle. On the other side, I put an external port for the USB connection. We've seen that a little bit earlier. This allows me to keep all the guts of the power cab inside the box, and I just plug in one thing. And lastly, one of the things that I learned from doing the Fremo stuff is they use these things called power pole, Anderson power poles. These are the 30 amp model. And these allow you to build your own connectors in order to connect things like I have, for instance, a cable that I'll have alligator clips on, and I can power up modules just by clipping onto the track and plugging into this thing right here. So all of that is kind of like grown over time where I've said, hey, you know what? I need this. And then I figure out how to make it work with the box. The programming track itself, you'll notice, isn't just standard flex track. I actually use PC ties and soldered the rails on. At some point, I keep saying I'm going to do it, I'm going to add a third rail on here that'll be gauged for N scale so that I can program N scale engines or HO scale engines. And it's just a matter of having one of the rails a little bit closer. It's gaps to it in order to be able to allow that. You have to gap the PC ties to keep the polarity or the rails from crossing. And then the other thing I did is basically made an analog to a KD coupler height gauge for each end because I need to be able to stop the engines. I'd hate to tell you how I found that out. So it's really important to have something to stop it. And I thought at the same time I might as well gauge coupler height. So everything has kind of been an evolving process, as I've said before. We'll take a look at the inside of this next. First, you'll notice there's a little panel here. It's actually a hatch so that I can get at various tools and stuff I have. I have jumper cables. I bring along my throttle in there. I'll have USB accessories for my computer and that sort of thing, and a power supply for the computer. I made this hatch cover so that I had a nice place to work normally. And if you flip it over, you'll notice that there is a lock or ESU decoder tester so that I can actually just take a bare decoder from any manufacturer. You can plug in a Soundtrax decoder or a Lock Sound decoder or a Digitrax decoder into this using one of the various inputs for it. It's a really nice decoder tester. I also have an NCE decoder tester that I use for doing accessory programming. Things like the switch it for turning turnouts and that sort of thing. I can set the addresses on here, check and make sure it works, and then while I'm at the comfort of my desk, and then go underneath the layout and put it where it needs to be. You'll notice that there's power pole connectors on the end of this. I can set it in to the hole here in this direction and just plug it right in to the power pole outputs. And that gives me power to this segment of the test kit. We can remove this then, put it over to the side, and I've left this so I can actually pull the whole thing out of the box. So one of the things I wanted to do is be able to easily plug in for the AC power part, the one that actually connects to household current. That's accomplished through this interface right here. I'll be giving John an actual shopping list of the parts that I got. You don't need to source them from the same place, but it's a good idea to be able to say, oh, that's what he got. This actually comes to the bottom side under here as this box here. And from here, it goes into a couple of standard AC power boxes where I've got normal sockets or electrical outlets here and also one inside. You notice that on the inside one, or the one that fits in the well, I have the wall wart or the power supply for the power cab system plugged in here. The one thing I do have to watch out for every once in a while, these things don't seat too well, so if it doesn't work well, I have to go in and make sure it's actually in the socket strongly. The other thing, as I mentioned before, the outlet here has USB charger outlets as well. That's really handy when you're working with this stuff. Let's look at the other side, the DCC side. This is the back side of the power cab panel. It has three outputs. There's the power supplied by the wall wart. There's the cab bus that, as I said before, goes to the USB connector. And then there's the actual DCC track bus that I have wired into the track right here, but also I go to a power distribution area here, which comes up to those power poles that I use that are actually really handy to have. I use green and white as my standard DCC bus. That's really not going to make many electricians very happy, but it's the standard that I've decided upon. So anyway, it's fairly simple. It allows me a lot of room to expand if I need to. There's a big well, if you look at it here, where you know, this goes into the box and you have a lot of room to store stuff. And it drops right in. Doing the woodworking stuff was a little bit of trial and error fitting. I took the basic measurements, drew out a plan on the wood, cut it out, and then had to kind of fiddle with it, especially the vertical supports. You've got a little bit of an angle on each side. The other thing that I found as I was working on this, kind of by trial and error again, is that there are some nubs that fit into the box that hold things up. And I had to figure out where to place them. They come down right in here, and you'll notice my mistake here. What I ended up doing is put some dots of paint on the nubs and had them come down and touch the wood, and I knew that was where I needed to cut out. So that's everything we have here. And it's really a handy box. I also have some pictures of where I've hooked it up to sections of layout to give it a test before I actually install track work and that sort of stuff. It's been really handy to have. It's not just for programming engines, it's for doing everything you'd want to do with DCC. So I've shown you how I've interfaced two different NCE systems to JMRI. Just requires a little bit different cabling, but the net effect is the same in both cases. I've also shown you how I put together my JMRI box that I use for programming or testing track or setting up turnout control and that sort of stuff. I'd really like to hear if you have any ideas for things you'd like to see if you started making your own JMRI box. It's always interesting to hear somebody else's idea, and it'll open up new vistas as far as, hey, this would be a cool thing to try with this and see if it works. I still have other projects I want to do with the box as well. I hope you've enjoyed this. If you have anything else you want to have us talk about for JMRI or NCE decoding or anything like that, please just leave a message in the comments. Thanks a lot.
All right then, thanks Murf, that was a really great demonstration. You know, when I saw that DCC box for the first time last year, I knew we had to do a show about it, and I'm really glad that we got a chance to do it this time. So now you've seen JMRI in action with a Sprague using no DCC system at all, and also with the two main players in DCC, Digitrax and NCE. As powerful as JMRI is, and as easy as the DCC manufacturers have made to integrate it with existing systems, it seems like a worthwhile endeavor to add it to just about any DCC-equipped layout. Even if all you do is use it to help program your decoders, it's worth it. I hope you've gained some knowledge and have been inspired to find out more. If you saw a product or a concept that you want to learn more about, check the description below first, and if you don't find what you're looking for there, head over to your favorite search engine, type it in, and then let us know what you found out by sharing it in the comments section below. You can download JMRI and get the answer to just about any question you may have about it at jmri.org. While you're there, consider making a donation so that it will continue to be free. So what do you think? Did you learn something new? Did we forget to mention something? Did you know that you can help ensure programs like this will continue to be made by supporting TSG Multimedia on Patreon? Head over to patreon.com/tsgmultimedia to find out more. Thanks for watching, and make it a great day.
So the first system we're going to look at is the NCE Power Cab, which I'm holding right here.
Don't do this to me.
Okay, sorry. Okay.
Oh man, that was so Vanna White.
No.
You remember Vanna White, right?
Oh yeah, that's where I was going.
Yeah, that was,
I'm
that
glad
was
you
good.
could relate.
That was very good.